So on 643, number 3, we're looking at 0.3420. 6.2867. 9.1184. 12, negative 3.7321. Negative 3.7321. 15, 0.6428. 18 is negative 0.9903. 21 is 0.2193. 24, 0.0843. 27, 0.9848. 30, 0.6959. 33, negative 0.5556. 36 is negative 0.3162. 39 is 0.9623. 42, all they were asking you to do here in 42 really is find the sine, cosine, and tangent of that 125-degree angle. They gave you the angle of 125, and then they wanted to know, well, what is the length of this vertical line segment? Well, the vertical line segment represents the sine. The horizontal one represents the cosine, and then the one out tangent to the circle represents the tangent. So all they're asking you for in 42 was the sine of 125, the cosine of 125, and the tangent of 125. So 42A is 0.8192, 0.8192. B, negative 0.5736. And C, negative 1.4281. 45, A and C are increase, B is decrease. So increase, decrease, increase. 48 is option number 3, as well as 51. 48 and 51 are both choice 3. And 54 is true. 54 is true. For quadrant 1 angles, the sine of the angle is less than the tangent of the angle. Okay, the sine of the angle is less than the tangent of the angle. That is absolutely true. Repeats on the first section. Oh, we had to go. Did we go up to 57? Yeah, 57 was 883. 883 on 57. Repeats on section 7. 883. Questions on 643? 57? Tethered balloon is fastened to the ground with a cable 1,000 foot long. It is blown by the wind so that the cable makes an angle of 62 degrees with the ground. So here's our ground. Here's our cable to the balloon. The cable is 1,000 feet long, and we are forming an angle of 62 degrees with the ground. The height of the balloon, they want to know how far off the ground the balloon is. Well, what kind of a triangle do we have here, folks? We've got ourselves a right triangle. Pythagorean theorem or baby trig? Why baby trig? Because we know one of the acute angles. Now, which side do we want to find according to that 62-degree angle? We want to find the side opposite of it, knowing the side that is the hypotenuse. Which trig ratio do we have to use? Sine. The sine of a 62-degree angle is going to be equal to that opposite length over the hypotenuse length, which is 1,000. So how do we undo division by 1,000? Multiplication by 1,000. Sine of 62, and then they wanted this to the nearest foot, so 1,000 sine 62 gives us then 882.9, so 883. And we're talking in what? Feet. 883 feet. All right, 57. Any others? Okay, to section 2 then, or section 8 really again. We were again divisible by 3. Number 3, we're looking at a 77-degree angle. 6 is a 65-degree angle. 9 is a 32-degree angle. 12 is a 1-degree angle. 15, you can have any one of the three ratios. Sine theta being radical 3 over 2, cosine theta being 1 over 2, or tangent theta being radical 3 over 1. You can have any one of the three. And you don't need your calculator for this. The sine of what angle is radical 3 over 2? 60-degree angle. It's a 60-degree angle. We need to recognize these radical 3 over 2s, 1/2s, and radical 3s as being the special angle function values. Sine is radical 3 over 2 at 60, or cosine is 1/2 at 60. Tangent is radical 3 at 60 degrees. No calculator on 15. 18, 19 degrees and 18.7 degrees. 19 and 18.7. 21 is 35 and 34.8. 35, 34.8. 24 is 21, 21.0. Do you have to have that 0.0 in Part B? Yes, they asked to the nearest tenth. We've got to show that place then. So 21 and 21.0. 27 is 44 degrees, 40 minutes. 44 degrees, 40 minutes. 30, one of two answers you can have. The better answer is 83 degrees, 0 minutes. But 83 degrees and 0 minutes is really the same as 82 degrees and 60 minutes. So 82 degrees, 60 minutes would be acceptable, but you really want 83 degrees, 0 minutes. 33, to the different degrees of accuracy. 33 degrees, 24 minutes. 33 degrees, 20 minutes. So 33, 33, 24, and 33, 20. 36 is 42 degrees, 41 degrees, 48 minutes, 41 degrees, 50 minutes. 39 is 17 degrees, 17 degrees, 27 minutes, 17 degrees, 30 minutes. 42, they gave you the adjacent and the hypotenuse. So the cosine of angle A is 7/9. So then inverse cosine of 7/9 is 39 degrees. So cosine A is 7/9, giving us 39 degrees. 45 is 75 degrees, 74 degrees, 32 minutes. And then 48 is no. Just because the function value is double the other does not mean the angle is double the other. And just because the function value is double of the other does not mean the angle is 2 times of the other. No, absolutely not. Repeats on 650. 36 was again 42 degrees, 41 degrees, 48 minutes, and 41 degrees, 50 minutes. Other repeats? Questions? 42. 42 says for each right triangle, the lengths of 2 sides are given. So A, write a trig ratio using angle A, and then find the measure of angle A to the nearest degree on 42. So we are referencing then angle A. So according to angle A, what is the side that represents the 7? That's the adjacent. 9 is the hypotenuse. So which trig ratio uses A and H? Cosine. So we'd say that the cosine of angle A would be equal to what over what? 7 over 9. A over H. So cosine A is going to be 7/9. So then part B, how do we undo cosine? With inverse cosine. The measure of angle A is going to be inverse cosine 7/9. Now how do we do that inverse cosine on the calculator? Second cosine 7/9 to the nearest degree. 38.9 would round to 39 degrees. If I would have known O and H, we would have had to use sine. If I would have known O and A, we would have used tangent. But knowing A and H, we use cosine. All right with 42? Other questions? Okay, go ahead and put those to the side. And we're carrying on into then 14.9. So 0, 2, okay, 14.9, a very, very important concept here with reference angle, and that's not the first time you've heard me say something is very, very important here in this topic so far. This whole chapter is vital to our further understanding of trigonometry. So it makes sense then that everything in Chapter 14 is going to be very important to carry on with. Reference angles would be at the top of the list of important things to carry on with. Okay? Take a look at the special angles we know. What are the special angles we know right now? Taking the quiz on the last 2 days. 0, 30, 45, 60, and 90. Well, all of those angles are found where? In the first quadrant. They're all found in the first quadrant. Well, what we need to do now is we need to extend outside of that first quadrant. We need to discuss second, third, and fourth quadrant angles. But wouldn't it be nice if there was a way for us to refer them back to a first quadrant angle? Because we know a lot about the 30, the 45, and the 60. Those first quadrant angles are easy to deal with. Well, there is a way that we can do that, and it's called with reference angles. Okay? A reference angle is going to turn a second, third, or fourth quadrant angle into an equivalent first quadrant angle for me. And all I'm going to have to do is potentially tag on a negative. Because if we're in quadrant 2 talking about cosine, in quadrant 2 cosine is negative. Or in quadrant 3, sine might be negative. So all we're going to have to do is tag on potentially a negative, depending on the quadrant we're in. But we're going to take a second, third, or fourth quadrant angle and refer it back to a first quadrant angle. So what we're going to have is a 30-degree angle, a 45-degree angle, and a 60-degree angle, not only in quadrant 1, but in quadrant 2, 3, and 4 as well. And since we already know their function values, all we might have to do is tag on a negative. For example, 120 degrees. What quadrant is 120 degrees in? It's in quadrant 2. Okay, that fits the category for a quadrant 2 angle. Now, I'm going to tell you then that the 120-degree angle behaves the exact same way as a 60-degree angle. Okay. A 120-degree angle has a reference angle of 60 degrees. So the sine, cosine, and tangent of a 120-degree angle is going to be the same as the sine, cosine, and tangent of a 60-degree angle, with the exception that we might have to tag on a negative because we're in quadrant 2. So how do we find these reference angles then? Well, first of all, we've got to understand the definition of a reference angle. The definition is vital to us being able to determine what a reference angle is going to be in quadrant 2, 3, or 4. A reference angle is an acute angle. What does an acute angle mean? Less than 90, greater than 0. Less than 90, but greater than 0. Formed by, and this is very important, these two things that form it. Formed by the x-axis, and again we can talk about the positive or the negative side with the reference angle. The positive or the negative side of the x-axis and the terminal side of our standard positioned angle. Those are the two line segments or the two rays that will form our reference angle. So for an example down here, I've got a quadrant 2 angle labeled theta. Theta is my quadrant 2 angle. But again, folks, I don't want to deal with a quadrant 2 angle. I want to refer it back to a first quadrant angle. I want to create a reference angle here. And the first thing I want to do is I want to draw that reference angle for you. What are the two sides that form a reference angle, folks? The x-axis, and it can be either side now. We're not just talking standard position positive. It can be either side of the x-axis. So the x-axis and the... So I like to start off with the terminal side. Okay. So right here is the terminal side of my angle. That is one of the sides of my reference angle. And then the x-axis. Well, folks, if we're in quadrant 2, which side of the x-axis is quadrant 2? the negative x-axis. So right there in green is our second quadrant angle, but then in red we have its what angle? So right here is the reference angle. I'm going to call that alpha. This angle right here, alpha, represents the reference angle of theta. Would that be an acute angle? Yeah, it's inside of a quadrant. It would have a measure of less than 90, greater than 0 and less than 90. So that's going to be our reference angle. That is how we will form reference angles. We will always start with the terminal side and then match it back to the x-axis, whichever is going to give us the acute angle. The question now then is going to be, well, whether we're in quadrant 2, 3, and 4, are we ever going to have to worry about a quadrant 1 reference angle? No. Quadrant 1 are our reference angles. We want to refer everything back into those. So all we're concerned with is quadrants 2, 3, and 4. Okay, now, the question is going to be is how are we going to find the measure of this angle? How are we going to find the measure of this angle? Well, let me give you an example first here. What if I were to tell you that this is 120 degrees? Okay, so Derek, you're saying that alpha then would be what? 60 degrees, and you are correct. So how did you get that then, Derek? You subtracted 120 from 180, and that's exactly what you're supposed to do. Now, what led you to believe to do that? Why 180? The negative x-axis measures at 180 degrees. And what I want to find is just this angle right here that's between the 120 and the 180. Well, how do I find the angle that would be between something? We would take its difference. So we're going to take 180 and subtract off that 120 to get the 60-degree reference angle. So now, folks, very importantly here then, the cosine, sine, and tangents of 120 degrees are going to be pretty much the same as the cosine, sine, and tangent of 60 degrees, with the exception that they might have a negative. Now, what would have the negative in quadrant 2? Cosine is negative in quadrant 2, and tangent's negative. So the cosine of 120 is the negative cosine of a 60. The sine of a 120, well, that's the same as the sine of a 60. The tangent of a 120, well, that's the negative tangent of a 60. Why negative in cosine and tangent? Well, they're negative in quadrant 2. But that 120-degree angle behaves the exact same way as the 60-degree angle does. So what would be a quadrant 2 angle that would have a reference of 45? What's the quadrant 2 angle that behaves the same way as 45? 180 minus what would leave me with 45? 135. 135 acts the same way as a 45. What's going to act the same as a 30? 150. 150 will be the same as a 30, with the exception of that plus minus. So very important, folks. We kind of started off the chapter saying we needed our angles to be between where and where? 0 and 360. And if it was outside of that, we would use coterminal angles, adding and subtracting how much? 360 to get us into that range. Well, now I'm saying, well, that 0 to 360 is way too much. That's still way too much. I do not want my angles to be between 0 and 360. I want them to be between 0 and 90. Between 0 and 90. How do we do that? Well, number one, we're still going to have to sometimes use coterminal angles, but then we're going to use reference angles. Okay, so we need to generalize now. How are we going to find a reference angle in quadrant 2? How are we going to find a reference angle in quadrant 3? How are we going to find a reference angle in quadrant 4? Well, you already told us quadrant 2. We already determined that back here. Okay, so if my reference angle, alpha, you said, how do we find this then? But now we don't have 180 and 120 or 180 and 135. Now we have 180, and from that 180 degrees, we have to subtract off what? In general here, what's that second quadrant angle? What's the measure of this angle right here? Theta. 180 minus theta. Theta is your quadrant 2 angle, so your reference angle is 180 minus theta. Okay, 180 minus theta. And again, that 180 minus theta falls in right here along the terminal side and then the negative x-axis. That's my reference angle alpha. And alpha is equal to 180 degrees minus the theta that we know. Again, based off the terminal side and the x-axis. Let's extend it into quadrant 3 again now then. Okay. Quadrant 3, again, a reference angle is based on the terminal side. So right here's my terminal side. And the x-axis. So quadrant 3, do we want to use the positive or negative x-axis? Yeah, we still have to use the negative. If we were using the positive, we wouldn't be getting a reference angle. We'd be given the same angle we've got here. Okay, so here's my reference angle alpha. Well, how are we going to compute alpha now? How are we going to find this angle right here that's in between theta and 180? How are we going to find alpha? Quadrant 2, we took 180 degrees and subtracted off theta, because theta was the smaller angle. In quadrant 3, what's the smaller angle? Don't make this more difficult than it is, folks. Right here's an angle theta, right here's 180. I want to find out what's in between theta and 180. How are we going to find that angle theta? Theta minus 180. We take the larger one, which is theta, and subtract off from that the 180. Notice, folks, are we using anything with 90 and 270? Absolutely not, because our definition of reference angle says it's based off the x-axis. We are not using 90s and 270s. We're only going to be using 180s. And over here, if we go all the way around, we'd be talking about 360. We're only going to be using 180s and 360s. Okay. So in quadrant 2, it's 180 minus theta. In quadrant 3, it's theta minus 180 to find our reference. Quadrant 4, again, let's graph it off first. We've got to use our terminal side and the x-axis. Well, if we're in quadrant 4, which side of the x-axis are we using? The positive side. So right there is my reference angle theta. I'm sorry, alpha. How are we going to find the measure of that reference angle alpha? 360 degrees minus that third quadrant angle theta. Okay, so very important, folks. You need to know how to find a reference angle in each of your 3 quadrants. Quadrant 2, 180 minus theta. Quadrant 3, theta minus 180. Quadrant 4, 360 minus theta. If you can't remember that, just understand what a reference angle is. It's an angle formed by the terminal side and the x-axis. So if you can draw it, then you should be able to determine how to find it as well. Okay? 180 minus theta for 2, theta minus 180 for 3, 360 minus theta for 4. Okay. Regents type questions. Express the following as a function meaning sine, cosine, or tangent, function of a positive acute angle. Folks, that right there is a huge clue into using what angles? This is a huge clue into using reference angles. Okay. So 260, that's easier. Can we clearly determine what quadrant 260 is in? Yeah, where's 260? 260 is quadrant 3. So if we want to express this as a function of a positive acute angle, we first have to determine what quadrant we are in. So I always like to put the quadrant right above the angle. And now that quadrant is going to tell me 2 things. It's going to tell me about the sign of my function, and it's going to tell me how to find reference. So tell me about cosine in quadrant 3. It's negative, so we need to tag a negative to that cosine. So negative cosine. What is positive in 3? Tangent's positive in 3, so sine and cosine would have been negative here. Okay. So that's the first purpose for finding your quadrant, is you determine if you're positive or negative. Now, if it was positive, we would have done nothing there. We just would have still had cosine. The second reason is to find reference. How do we find reference in 3? 180 minus theta, theta minus 180, or 360 minus theta? How do we find reference in quadrant 3? Theta minus 180. Now, what is my theta? What is my third quadrant angle? The 260. So we're going to take 260 and subtract off the 180 degrees to give us that positive acute angle. We're looking at the negative cosine of 80 degrees. The negative cosine of 80 degrees. Do we now have a positive acute angle? Is 80 degrees positive? Is it acute? Is it a function? Yes, it's the negative cosine of an 80-degree angle. Now, again, what's really nice here, folks, can we verify this? Can we check it? Absolutely we can. What did we start off with? We started off with a cosine of 260 degrees. What did we end up with? Negative cosine of 80 degrees. Same thing? Are we correct? Yes, absolutely are. So reference angles are going to be able to put us into that quadrant 1. This one, there's one more step involved in this. Negative 80, is that really what we want? No, we ultimately want to be between 0 and 360. So what's the first thing I'm going to do with this negative 80? We're going to add 360. I can't look at negative 80 and easily determine what quadrant it's in. Yeah, it's in 4. But if it was negative 215, well, you're thinking, well, 215, that would be quadrant 3, but it's negative, so it's rotated clockwise. It's just easier to find a coterminal angle if you're not in the range that you need to be. So this is really the tangent of, what's negative 80 plus 360? 280. We're looking at the tangent of 280 degrees. Now, can I determine what quadrant we're in? Yeah, where's 280? That's quadrant 4. So I write that above my angle. I'm in quadrant 4. And I do that for 2 purposes. The first purpose is to determine the sign of my trig function. Quadrant 4, is tangent positive or negative? It's negative. What is positive in 4? Cosine is positive. So tangent is negative in 4, and then the second purpose for the quadrant is determining the reference. How do we determine reference in 4? 360 minus the theta. Now what's the theta that we were given? 280. 280. So ultimately here then we get negative tangent. What's 360 minus 280? 80 degrees. Okay, do we have this expressed as a function? Yes, it's negative tangent. Is my angle positive and acute? Yes, it is. Can I check and verify this? Yes. What did we start off with? So tangent, negative 80. I get negative 5.67128,182. What did we end up with? Negative tangent 80. Do we get the same thing? Yes. Now if we don't, folks, can we go right down the line and check all of these? Yeah, if this was wrong, then I would go back here. Well, maybe the 280 is wrong, so I could go tangent 280. No, that's the same thing. That's right. I can go line by line and verify these. So I can easily see where my mistakes have been made if we don't go through those. Let's add one more step to this. Let's find the exact value of the sine of 120. Folks, what does exact value mean? Fractions and radicals. No decimals. Stay away from. Used only as a check. Okay. Sine of negative 120. Do we want to deal with a negative angle? No. So what's the first thing we're going to do with this negative 120? We're going to add 360 to it. So we get then the sine of sine of 240 degrees. Now can I determine the quadrant we're in? Yeah, where's 240? 240 is in quadrant 3, where sine is negative And we find reference how? Subtracting off 180. So we've got 240 minus 180. So we've got the negative sign of a -60-degree angle. The negative sign of a 60-degree angle. Well, do we know the sign of a 60? Absolutely do. What's the sign of a 60? Radical 3 over 2. We just need to tag on the negative. Negative radical 3 over 2. Can we still check this? Absolutely we can. We can still take the sine of negative 120. Sine negative 120 equals that. We got negative radical 3. Make sure you close the radical, divided by 2. Are we correct? Yes, absolutely we are. 120 degrees behaves the same way as a 60 degree. Okay. We've got to finish this up yet. There's no homework assignment for you tonight. I want you to read 14.9. Read 14.9. Folks, you will be able to get a good start on the homework assignment. You're going to be able to do some of these beginning problems with the two examples we've just done. You should be able to do both of these sets right here. Okay? With what we've done already and your reading of 14.9. Okay, but we will finish this up tomorrow then.